let us consider again the mother graph of tan theta drawn in green here. And now we want to do the graph of G, which is double 2 times tan of theta. So, like before, we take each value, like for instance at the point E, multiply that by 2 and get a new dot. So 2 times 0 gives me 0. If I look at the point F there, which is at 45 degrees, we get a value of 1. If I multiply by 2, I get the value of 2, which is P, and then make a dot there. The same if I take D, which is negative 1, the Y value, and I multiply by 2, I get the value of minus 1. It's very important to embrace these values at the multiples of 45s and minus 45s to know where to stretch a tan function. So once we've done all our dots, we can even use another one. In this case, we can read off that value there and just make another dot there, etc. But these three, because we know the general form of the tan graph, is sufficient to do the stretching. On this page, I've just joined the dots that we made on the previous page, and again, we need to look at the period, etc., etc. So again, we see that although we stretch it vertically, it did not change the period. So the period stays at 180 degrees. We do not have any amplitude because we do not have a minimum or a maximum value. So if I look at the roots, I see it happens exactly at the same place as before. It's again at D, E, H, and K. In order to write down a formula, we again see that it's exactly the same as before. So we can just write down my theta will be K times 180 degrees. So K element of Z. Again, we can test our formula by substituting values for K into the solution. Again, we see there's no extremes, and then we have to look at the vertical asymptotes. We see we have vertical asymptotes in exactly the same places as before, so we will again write theta equal to 90 degrees plus K times 180 degrees, K element of Z, which I can rewrite as 2K plus 1 times 90 degrees, and just like we did with the regular tan function. Again, we see the concavity changes there. Although the function is vertically stretched out, it still has a curve upwards for those values, or the part of the graph above the horizontal axis, and below the horizontal axis it's still concave down. The next page is again a summary of what we've said before, and remember, just note here that we always indicate the vertical asymptotes by the broken line, by any broken line. So in this case I prefer to draw the graph, the mother graph, which is in green here. Use the green there, but if you want to draw the red graph, we will also draw the red broken line, which is exactly the same as the green in this case.